Welcome to SUS303. I hope you enjoyed the first day of re:Invent so far. My name is Sam, and I'm leading the sustainability pillar of AWS Well-Architected Framework. Today, I'm also pleased to be joined by my colleagues, Thomas and Chi. Thomas is a principal technical account manager with us, and also Chi is analytics specialist solution architect from AWS Japan. As you can see here, we are going to talk about how you can deliver sustainable, high-performing architecture on AWS. So this is the agenda for today. So first of all, I will start to set the scene by talking about the environmental sustainability and its urgency. Also, to better help you understand the sustainability transformation, I will cover our own sustainability journey in Amazon and AWS and talk about some of the key initiatives. Then I will cover how we can help you as a technology partner in your own sustainability transformation journey. That's going to include diving deep on some of the tips and best practices that you can use to deliver sustainable, high-performing architecture on AWS. And finally, to demonstrate how you can use these tips and best practices, we are going to use modern data architecture as a sample workload and demo how you can make that more sustainable and high-performing. All right, let's kick off the presentation with the topic of environmental sustainability. We all know that we need to deal with the climate change. In fact, scientists tell us that we have a limited window to limit the global warming by 1.5 degrees. We need to get to net zero carbon by 2050 to avoid the damaging consequences of the global warming. And to achieve that, we need to reduce the carbon emission by approximately 5% on a yearly basis. And delay on that, it's just going to increase the required drop needed in later years. To get a better understanding of this number, we had such a carbon reduction during a pandemic in 2020, so which means one pandemic each year. Obviously, this is not what we want, but this is the systematic change that we need in order to limit the global warming by 1.5 degrees. Our customers come to us and ask how they can start this systematic change in different parts of their businesses, including IT. Obviously, digital technology can be a key enabler to achieve this systematic change. In fact, tomorrow's strongest performing companies are likely to be twin transformer, companies that find value at the intersection of digital technology and sustainability. Now, the next question that you may have is how digital technology, and especially AWS cloud technology, can help you to achieve this systematic transformation. And to answer that question, I'm going to quickly go through the sustainability journey in Amazon and AWS. We understand that sustainability is a journey, and we are also in this journey and tackling initiatives after initiatives to make progress. On this slide, you see the types of initiatives that we've been taking on to drive sustainability impact and transformation for our various businesses. To highlight some of those, we can talk about the Amazon Sustainability Report, which was initially published back in 2019, and we recently published our fourth report in 2022. Also, Amazon is the largest corporate buyer of renewable energy globally. One of the key initiatives of our sustainability transformation was started in September 2019, when Amazon announced the Climate Pledge with partnership with Global Optimism. This was a commitment to be net zero 10 years before the Paris Agreement, which has set 2050 as the global net zero carbon goal. We have public stated goals in these initiatives, which includes net zero carbon by 2040, powering our operation with 100% renewable energy, which we initially committed to reach by 2030, but we are now on the path to reach that by 2025, and also a $2 billion equity fund so that we can help the world find and build sustainable solutions. The Climate Pledge is open to all companies. There's just 3 key principles for others to join this pledge, which includes regular reporting, carbon elimination, and credible offsets. We already made good progress with more than 300 signatories across different countries and industries join the pledge. In addition to highlighting what Amazon has been doing as the whole business along the sustainability transformation journey, AWS is also working hard to transform for sustainability. Not surprising, our focus has been on our data centers and how we can operate to reduce the carbon emission. As you can see here, AWS has multiple initiatives to use water more efficiently and use less drinking water to cool our data centers. And you may have heard the announcement that we had today that we are on the path and we pledge to be positive water by 2030. Also, to help customers to reduce the carbon footprint, AWS Graviton-free processor, just like Graviton2, are more energy efficient. And Graviton-free based instances use up to 60% less energy compared to the traditional EC2 instances. We also developed the AWS Customer Carbon Footprint tool to help our customers do the carbon reporting of their cloud workload. All right, so far we discussed how the different types of initiatives for sustainability that we got in Amazon and AWS. Now let's talk about how AWS can be a technology partner and help you achieve your sustainability goals in the cloud. To talk about how AWS can help you in your sustainability journey, we need to first understand our shared responsibility model that we got for sustainability. Just out of curiosity, how many of you are familiar with this shared model? All right, just half of that, India, I would say. So, in this model, environmental sustainability is a shared responsibility model between AWS and our customers. So AWS is responsible for optimizing the sustainability of the cloud, which means delivering efficient shared infrastructure and also sourcing our data centers by renewable power. And customers on the other side are responsible for sustainability in the cloud, which means optimizing workload and resource utilization and minimizing the total resources required to be deployed for a specific workload. Based on this shared responsibility model, there are three main ways that AWS can help you in your sustainability journey. Firstly, migrating to AWS Cloud can reduce the carbon footprint of your workload as compared to managing that workload in on-prem data centers. Also, you can leverage AWS capabilities, such as our process teams or our data initiatives, to build solution on AWS and achieve your sustainability goals. And finally, AWS can help you to optimize your workload on AWS through the frameworks and toolings that we got and we're going to cover in this presentation. Let's dive deep on each of these and see how AWS can help you on those. As I mentioned, you can migrate any types of workload, application, database, or even entire data centers from on-prem environment to AWS. Through our scale and focus of innovation, we can achieve higher resource utilization and also energy efficiency compared to a typical on-prem data centers. According to 451 research, compared to an on-prem data centers, AWS can lower a customer carbon footprint by nearly 80% today and up to 96% once the AWS is powered by 100% renewable energy. AWS infrastructure is 3.6 times more energy efficient than the median of US enterprise data centers, and also up to 5 times more energy efficient than the average European enterprise data centers, and 5 times more energy efficient than the average on-prem data centers in the Asia-Pacific region. This is how migrating to AWS can help you reduce your carbon footprint and also achieve your sustainability goals. Depending on your need, we can also help you through our process sustainability practice or our partner program to build solutions for sustainability use cases and transform your business. Almost all industries have a set of shared challenges. This generally includes things like facility management, design and optimization, and even carbon tracking and footprinting. Our AWS process teams has developed a deep experience working with clients on sustainability use cases, including Amazon as a client. They have a team of sustainability technologies who can work with you on various types of use cases, leveraging their experience and learning. Data is the core for all sustainability solutions. Many of sustainability solutions also require or even can be improved by external data sets. As an example, you might be able to design a better cooling system if you know what is the temperature outside. We have 3 key programs that offer data for sustainability. We have the AWS Open Data Program, the Amazon Sustainability Data Initiative, or ASTI, and the AWS Data Exchange. You can leverage these programs and the available data set to develop new cloud-native solution and address your sustainability goals. All right, so far we discussed how migrating to AWS and building solution on AWS Cloud can help you in your sustainability transformation. Now let's talk about how you can optimize your workload on the cloud and make it more sustainable and high-performing. To deliver a sustainable, high-performing architecture, you need to design and implement 2 key capabilities in your architecture. Firstly, your architecture should be resource efficient. Let's see, what does that mean? So resource efficiency means you should use the cloud resources efficiently in your architecture in order to meet your business requirements. And also, you should maintain that level of efficiency as the demand changes or even the technology evolves. Your architecture should be also impact aware, which means you need to enable visibility in your architecture so you can see the resource footprint and utilization, and also you can use these data to evaluate how different techniques can help you to lower the carbon cost of your workload. To help you enable these capabilities in your architecture, we provide you with a number of frameworks and toolings on AWS. So on this slide, you can see a list of some of the key frameworks and tooling that we got that can help you to make your architecture resource efficient and also impact aware. Let's go through each of these frameworks and tooling. We start with the AWS well-architected framework. So AWS well-architected framework helps you build secure, high-performing, and also efficient infrastructure for a variety of application and workload on AWS. We traditionally had 5 pillars in this framework, but back in reInvent last year, during our CTO keynote, Warner Vogels, he actually announced sustainability as the 6th pillar. So the sustainability pillar enhances the framework by providing a way for you to consistently measure the architecture against sustainability best practices and identify the area of improvements. It contains questions aimed at helping you evaluate the design, architecture, and even the implementation of a workload to reduce the carbon footprint and improve the efficiency of your workload. To better understand the well-architected sustainability pillar, let's look at a typical cloud workload and its component. Good. So whatever you build as a cloud workload, it is usually in response to a need or request from your business. These requests may come from a user or from an application. For example, when you are building an analytics workload, you use this workload to generate report and insight for your business users. So your business user requests and access those reports, and your cloud workload in the background generate those reports. To respond to those requests, you start to provision cloud resources on an AWS region, which is a separate geographic area that AWS uses to house its infrastructure. All these resources that you provision make your overall architecture. And your architecture usually includes several subsystems. And by subsystem, we mean a group of resources that work together for a specific objective and can be decoupled from the rest of the architecture. For our own example, for the analytics workload, we usually provision subsystem including data ingestion, data transformation, and data processing. Each subsystem in your architecture have a different response time and speed, and the combination of all these makes your workload response time or speed, or what we call it as a service level agreement or SLA. And the last but not least, to enable automation and operational excellence within your architecture, you usually adopt some software development and deployment practices in your team, such as CI/CD or having a different environment for dev, test, and prod. These are the typical components of a cloud workload, and AWS well-architected sustainability pillar touches all these areas and provide you with the tips and best practices to just use to optimize those workloads for environmental sustainability. There are 6 focus domains within the sustainability pillar that you can see here. So the focus domains include the region selection, user behavior, software and architecture, hardware, data, development, and deployment process. Let's go through each of these focus domains. We start with the region that you choose for your workload. Last week, we published a blog that explained the 2-step process that you need to use to select a region for sustainability. You should choose a region for your workload based on both your business requirement and also your sustainability goals. Factors such as compliance, cost, and even available services and features play an important role in shortlisting the potential region for your workload. So if those business factors can allow you, you can start to think about adopting regions which are either near Amazon renewable energy projects or region which has lower carbon intensity. We recently published a list of AWS regions powered by more than 95% renewable energy in our own sustainability page and the link that you can see in this slide. So if those regions can address your business needs, deploying your workload in one of those regions can significantly reduce the carbon footprint of the workload. The second focus domain in sustainability pillar is around the way that you optimize the response to the request that you get from your user or from application, or what we call it as a user behavior pattern within the pillar. You should always use the elasticity of the cloud and the auto-scaling capabilities to make sure you have the right utilization level for your resources. Also, make sure to optimize the resources which are used by user for the activity that they perform. Again, for our own example, if your business user accessing the report through a desktop application, you need to make sure that that application which is running on that devices are efficient. Aligning your SLA with your sustainability goal is one of the key focus in this area. One key recommendation that we have for our customer is to review the SLA and negotiate impact-friendly SLA. So you need to redefine your SLA to just meet the business requirements, not exceeding them. In other words, you need to make a trade-off that significantly reduces the carbon footprint and the environmental impact in exchange for acceptable decrease in quality or increase in response time. Data is another key area in sustainability pillar. The focus here should be on optimizing the data storage and data movement across the network. And the first step to achieve that is to have a proper data classification in place based on your business requirement, so you can choose the right storage tier for your data sets. Also, to optimize the retention of those data sets, automatic lifecycle policy need to be implemented to delete unnecessary data sets. In addition, you should consider strategies that can minimize the data size and the data movement across the network. As an example, using efficient file format, such as Parquet or ORC, can help you to reduce the data sets by up to 87%. And the last but not least, do not back up all the data sets in your workload. Just check to see if it is impactful or if it is impossible to recreate those data. Another key focus domain of sustainability pillar is around the hardware and the way that you optimize those for energy consumption and utilization. Whether you have a self-managed workload on Amazon EC2 or you are using managed services, you can leverage Graviton-based instances in AWS for general purpose use cases. As I mentioned before, Amazon Graviton free-based instances use up to 60% less energy compared to the traditional EC2 instances. Also, for a specialized workload, such as deep learning, try to just leverage the specialized hardware. So we got the AWS Trainium and Inferentia, which are actually optimized for those types of use cases. So if you use those hardware for deep learning, those workloads are going to be more efficient and consume less energy. And finally, to make sure you have your workload have resources with least impact, you should always consider right-sizing opportunities. AWS provides several tools, such as AWS Compute Optimizer, that provide right-sizing opportunities and recommendation. Leverage those recommendations to make sure you are using hardware with least impact in your environment. Architecture and software is another aspect of sustainable workload. Here also, there are a number of different best practices that I can share, such as removing components with low or no use, or using architecture patterns that best support the data access and data storage. But one of the key focus should be around optimizing the architecture for asynchronous or a scheduled job, or what we call it as a sustainable scheduling. Let's consider a workload that it got this demand curve over time. So as you can see, the workload has two peaks around these two areas. And to address those two peaks, we have the provision capacity, as shown by this blue line, to just address those two peaks. One thing to consider is the fact that the resource and energy used by the workload is not indicated by the area under the demand curve. In fact, it's the area under the provision capacity. So now, let's consider scenarios that you are able to drive those two peaks down, either because you distribute the work throughout the day or because you implemented a queue to just smooth the demand curve. By reducing those two peaks, you can dial down the provision capacity, resulting in less resources and energy to be used for the workload. This is how sustainable scheduling, just through the architecture patterns, such as event-driven architecture or queue-based architecture, can help you make your workload more energy efficient and also sustainable. And the final area, which is the software development and deployment processes. Here, you should make sure to adopt more automation, as it can improve the sustainability of the workload. Also, if you are using different environments such as dev, test, and prod, make sure that you have a right utilization level for those environments. In addition, keeping operating system libraries and applications up to date is another key aspect that can improve the workload overall efficiency and also enable easier adoption of efficient feature and technologies. All right, so we covered all those 6 focus domains within the sustainability pillar. So those focus domains include all these tips and best practices that you need to manually go and just develop and test and implement it in your workload. AWS also provides some toolings, as listed in this slide, that can proactively check your workload and provide you with the area of improvements. As an example, AWS Compute Optimizer can identify compute resources, such as EC2, which are whether underutilized, and recommend you with the other types of instances that can just improve the overall utilization. Or Amazon Code Guru can find the least performant line within a code and provide you with the actionable recommendation to improve those lines. You need to use the recommendation from these tooling in conjunction with the best practices within the sustainability pillar to identify the potential area of improvement for your workload. Okay, so we discussed the sustainability pillar best practices and also the toolings that can provide you with some recommendation and potential area of improvements. Now let's talk about the second capability that I mentioned before. So I said we need to make the in order to make the architecture sustainable and high performing, there are two capabilities. Resource efficiency was one, and now the second capability, which is make the architecture more impact aware. But first, let's see why we need to make the architecture impact aware. To answer this question, we need to first understand the process that we recommend to our customers to follow and evaluate improvement for sustainability. The improvement process outlined in the AWS Well-Architected Sustainability pillar is an iterative process similar of how we are improving for cost and performance for decades. Let's say you are tasked to improve the resource efficiency of your workload by X%. So this is going to be the sustainability improvement goal for your workload. Now, to address this goal, you need to start to review the sustainability pillar best practices and also any recommendation from those tooling that I covered in previous slide to identify the area of improvements for your workload. After you identify those improvement targets, the next step is to evaluate those improvements. So evaluation starts with prioritization. So we all know that teams have limited capacity and time, so all these potential area of improvements need to go to the backlog and be developed based on the priority. Based on your business requirements, you may need to consider different factors such as risk, cost, and effort required to develop those. And for those scenarios and improvement target that got the higher priority, then you need to start to just validate those improvement targets. But in order to validate those improvement targets, you need to enable visibility in your architecture. Or, in other words, you need to make your architecture impact aware. And if you are happy, and when you're done with the evaluation phase, and if you are happy with the impact that those scenarios can make in your architecture, then you can just start to deploy those in your live environment and replicate those success and get those learning to just find another area of improvement for your workload or even other types of workload. In AWS, there are a number of services that can help you to build this capability for your architecture. And to cover those tooling, I would like to ask Thomas to join me on stage and talk about those tooling and services. Thank you.
Hello, everybody. If you can hear me okay, I'd like to talk through some tools that you can use to make your workloads impact aware and therefore performant with efficiency. So the first one that I'd like to cover is the customer carbon footprint tool. Last year at reInvent, we provided the customer carbon footprint tool, which allows customers to understand their carbon footprint of the workloads that they're running on AWS. It lets customers report on the real carbon emissions that are estimated using our tools to show the sustainability reporting, which you can use within your own reports. How many of you guys are using the carbon footprint tool so far to look at the output of your workloads? Just a few. Okay, and hands are going up more and more as we ask that question. But let's find out where it is. I'm going to show you how to use it so you can use that on your workloads in a moment. The people who are using it, they're already taking advantage that the customer carbon footprint tool automatically calculates the carbon footprint of the entire portfolio of services you're using. You can understand your historical carbon footprint and review changes in your emissions over time. That's very important from the sustainability perspective. For users of AWS organizations, you can see the impact of your whole estate. You can assess the impact of your emissions as they evolve, and you can see the changes that you make over time. Multiple charts are provided so that you can track emerging trends on your footprint, and you can plan future deployment strategies using the strategies that Sam talked through. Let's check out this tool. This is what it looks like. You can find it under the billing section, the reporting billing section underneath the cost and usage reports. It's just at the bottom. You can see the emissions generated by your AWS workloads, and you can see your estimated carbon emission savings. And that's using the 451 report, which, again, Sam talked through earlier, so you can see the figures, and you can look at that report yourself. You can see which geographies your emissions are made in, so you can make the decisions required to get your workloads running in the right regions, again, as Sam discussed. You can also see your path to a renewable workload, and you can see the output of the efforts that you're making in the model, the shared responsibility model, and the efforts that AWS is making within that graph. But this is just one number, and if we want to track improvement over time, we need to do it in a much faster kind of click when we do releases. The carbon footprint tool is releasing information every month, and it's offset. So we need to be more fast. One metric is not enough. We need to be workload specific. So far, I've explained that the customer carbon footprint tool is great for reporting your emissions, but as you begin to focus on workload optimizations, you'll find it more useful to find additional tools and data sources. So for that reason, I introduced the concept of a proxy metric. A proxy metric is where we show directional improvement in the carbon footprint. In a proxy metric, we focus on resources which directionally reduce CO2 output. And we can do this on a release-by-release basis. There are three metrics types that we generally look at. We look at storage, we look at compute, and we look at data transfer. When you evaluate these specific changes, you also need to evaluate which metrics best quantify the effect of the change on the associated resource. We have many metrics, and we need to see which metrics to choose and how they interact with each other. Let's look at what metrics make sense. We need metrics that can be measured frequently, delivered in a timely manner, which we can break down over application teams so we can make actual change as developers and DevOps people within these teams. The teams need to say the release on Monday had a good or bad influence on our sustainability metrics. The metrics also need to align with resource usage so that they're tangible within those application teams as workload use goes up and down. We can look at resources such as compute, storage, and data transfer, as we discussed. It's important not to look to just optimize one metric, because the metrics sometimes compete with each other. By storing our data sets in one region, for example, you might save resources on storage, but you might need to spend more resources on data transfer to support customers globally. So you need to understand your workloads as well. Another example is you may reduce compute by putting a cache, but then that offsets against other metrics. In the same way that metrics compete with each other, as we just discussed, sustainability metrics compete with non-traditional, with non-functional requirements, such as availability or response time. Your sustainability KPIs are yet another non-functional requirement. You should consider trade-offs, as we do in architectural decisions on a daily basis. Consider cost. Moving processing work from end-user devices to your application might increase the cost of your application running, but it will reduce the demand on the end-user devices, which if we look at the larger kind of circular economy, if you've got a smartphone, you might not need to replace it next year, and that's a really, really big advantage. Also talking about SLAs, as Sam mentioned, reduce the number of results is sometimes quite possible. We need to make business decisions based on our systems. Sometimes it's enough to provide an overview. There are hundreds of results to make that decision, as opposed to providing an exact number. Remembering that we're focusing on resource use within our proxy metrics to see what we have to optimize, we should avoid the pitfall of thinking that we should just look at resources on their own. When your usage is the same, for example, within a workload, but your user base is decreasing and therefore your load on the system is decreasing, that's cause for alarm because the resource usage should go down as well. And we need to make sure that we factor in business metrics to measure efficiencies given the resources over the business metric. An example of this, because when I heard this the first time, I did find it quite hard to understand. For example, if you're an automotive customer, maybe measuring vCPU over connected vehicle mile would be a good example. or maybe megabytes per storage of a customer, for example, in another workload. Later on, my colleague Chi will be doing an example where we take the data of all the taxi rides in New York in a glue workload, and we'll be taking the compute over taxi rides, so that we have that example there. Let's look now at places where we can get those resource metrics, where we can get the top of that division, and later we'll be thinking about the business metrics. We talked about the customer carbon footprint tool earlier, and I'd just like to remind you that that's giving data on a monthly basis, but we need to make those decisions faster. CloudWatch is a good example where metrics are delivered fast. By default, many services put metrics into CloudWatch for free on a regular basis, which you can use. So EC2 is a good example, EBS is a good example, as is RDS. You can enable detailed monitoring for more granular information. Data is kept for 15 months, which allows you to see your sustainability improvement over time. The cost and usage report is another great resource for getting information from. It tracks your AWS usage and provides estimated associated charges with the account, but that's not all. It's giving you information about usage as well. Each report contains line items which are unique to the combination of services that you're using, usage type and operation within your AWS account. You can customize the AWS cost and usage report, which we'll probably call CUR later on in our conversation, to be aggregated by hour, day, or month, so that you can put that into your reports for sustainability. Let's look at some examples of, we know that we need to get resources, and we know that we need business metrics. Let's think where we get those resources, and let's look at some examples. As defined in the well-architected pillar for sustainability, we think about compute, storage, and network first normally. That's the low-hanging fruit, normally with a view to reducing them. Compute-wise, we have data within the CUR and CloudWatch. Often in optimization of compute, we think about changing CPU types, or we think about right-sizing. One example, which we've already mentioned, was a move to Graviton. For that reason, we recommend using normalized CPU, so that if you do make those changes, you can compare apples with apples, so that you can compare number of cores, for example, and then this comparison works over that time. Storage-wise, we need to track how much storage we're using and how many times we access it. Think about using S3 storage lens, which Sam mentions, to see which tier is the most sustainable choice for you. Network metrics can be gained, for example, from CloudWatch, network in, network out. It's just the EC2 level. I'm sure your architectures are more complicated than that. You may want to think about getting metrics from our recently released logging from Transit Gateway, where you can see the traffic going in between VPCs and other connections into the Transit Gateway. Following on to the last stage, which Sam talked through, where we evaluate and we need to visualize to be impact aware so that we can get that resource optimization. There are a few tools that AWS offers you to use. QuickSight's one of them. It lets you visualize over multiple data connectors, including CloudWatch and the CUR report. And we'll be checking out an example later on of how to customize the cloud intelligence dashboards and CUDOS to do that. You can also use Grafana, and you can also use CloudWatch to do this. It tends to be around where your data is and what your data looks like and how your user is going to access that data. Here's an example of how we can tie all of that together. This is available on a well-architected lab as well. The purpose is that you need to establish dashboards with KPIs at a team level so that each team can gain their own goals and can work on those optimizations independently. Many of you will be familiar of using the cost and usage report for the sake of cost showbacks. It's a great resource for that, but also don't forget that you have that resource data in that file as well. You can combine that with further metrics, which we'll be demonstrating later on in an end-to-end demo from CloudWatch, where you can gain business metrics and you can query them in Amazon Athena. Start with establishing a dashboard, just a few KPIs, and go from there. What you need to bring as the SME within your business is that business KPI. Many add it to CloudWatch, as a custom metric. That's one way to start. Other people add it to S3 as a data set, which can be queried through Athena. And again, we'll be demoing that later on. Alternatively, if people can't think of a business metric, because sometimes it's more complicated than that, people tend to think about using the same metric that they use to scale their workloads. For example, messages going into a queue system, for example. One way to get started really fast with being impact aware within your workloads is to take the Cloud Intelligence dashboards. So what are they? They're a series of in-depth, customizable dashboards provided at free of charge from AWS. Many of you may be using them already. It's self-service. It's deployed quickly, again, as a well-architected lab. It's normally just 2 cloud formations that are run. It's a great starting point, which AWS will grow over time. Sustainability-wise, out of the box, many of the dashboards contain information which is particularly relevant. For example, resource usage of GP3 or movement to Graviton. It also highlights items which may not be utilized that you may not be thinking about, such as load balancers. Data is taken from the cost and usage report, which we introduced earlier, and it optionally takes information from AWS budgets. It gains information from other accounts using organizations as well. Trusted Advisor and Compute Optimizer are also inputs to some of the dashboards that you can see at the bottom. It's a great starting point. The bit in the middle, that's the bit that saves you the time, because that's where AWS has written pre-written Athena queries, which query the Kerr report, which has its complexities. The output is 6 dashboards, which can be customized in the ways that we're going to see later on. Because of this technology, it gives us many kind of hooks that we can customize. CUDOS is the most popular dashboard, and it gives a comprehensive detail on items such as idle NAT gateways, particularly good for sustainability. KPI dashboard's very useful. I use it on a weekly basis. It's great for sustainability to track KPIs like adoption to types that you've seen, instance types. Theories that you have can be hard to roll out over large estates that no doubt many of you run. So what we're going to do is we're going to customize one of the dashboards using the integration points that we saw earlier. We're going to take this graph, which comes from CUDOS, and we're going to change it so that it's no longer showing cost, but it's showing resource use in hours, which is more prevalent to tracking sustainability. And we're going to scale that y-axis using the business KPI, taking the abstract advice in the division earlier and applying that to a real workload. So to customize this CUDOS dashboard, QuickSight allows you to share a dashboard to an analysis, but there is a trick. That you need to give permissions for that. So you need to just go to the permissions within the dashboard and allow save as. That will give you a new save icon, which allows you to share the dashboard to an analysis, which is an editable dashboard. When you're in there, here's an example of a customization that you can do. We're changing the cost out for the usage quantity. So straight away, you're no longer reporting on cost, you're now reporting on usage hours, and you can start using that to be impact aware. Earlier, we talked about the data flow of the Cloud Intelligence dashboard system as well. We talked about the architecture, so we can see where we can put additional hooks. For this change, where we're aiming to scale the y-axis by the unit of work, we need to change the actual view within Athena. And you can see that here I've simply added a join to our business metric, and I would use that by changing the select to do that division. So we have the usage within hours, and we also have the business metric, so we can do that division. So now what we're going to do, we're going to change gear a little bit. We want to get less abstract. We want to talk about how we would take an example workload to be impact aware. Customers are storing more and more data and needing to query it to gain business value. Sam articulated this earlier as modern data architecture. It's designed to store and transform as needed data and query at scale. I'm just going to give a little introduction to what we mean by that. Modern data architecture is a documented approach to analytics at scale. It has 5 major areas. Having a scalable data lake means setting up and managing a data lake. This takes a lot of manual activity around governance regularly. We have AWS Lake Formation, which automates this for you. The next part of modern data architectures includes the purpose-built analytics solutions that we provide, giving you a wide range of tools for the use cases that you bring. Examples are Redshift and Glue, and we'll be covering Glue in quite some detail very soon. We're going to focus on the third bit, which is seamless data movement, where the data is transformed for use, and we'll be linking that to performance and effectiveness as well. I'd just like to also call out that there was a new blog released within the last 2 weeks that talks through sustainable approaches to every single one of these. So we'll be providing links to that as well. So with that, I hand over to Sam and Chi again to go through an example of making a workload impact aware.
As I said, for your own case, also you need to focus on subsystem so that you can see the impact in overall architecture. So for our demo, what we are going to do is we are going to focus on this seamless data movement and transformation pillar within the modern data architecture. And we are going to use AWS Glue, which is a popular service that our customers use for data movement and data transformation. So Chi, do you want to join me and just quickly talk about the use case and also the AWS Glue?
Sure. Thanks. And yeah, we'll start. So Sam, let's start to introduce AWS Glue. AWS Glue is a serverless data integration service powered by Apache Spark, an open-source distributed processing framework. This is a cost-effective tool which can be used by data engineers or data scientists to do data movement and transformation. At this demo, we will use 2 datasets. The first one is New York taxi trip data, which is a public dataset available in Registry of Open Data on AWS. This dataset consists of taxi rides log in New York City, including date, time, location, and fare. And sorry. And we also get taxi zone mapping data from New York Open Data Registry. For the purpose of this demo, Spark script is developed in AWS Glue to join these 2 datasets and determine the average fare per taxi zone area in New York City, and store our summarized data back in S3. For the best case scenario, data is stored in CSV format. The Spark version for Glue job is set to 2.4. And the other Glue job parameters are set to default. Let's start to see how we are going to improve this Glue workload for environmental sustainability.
Just before she starts, just want to reiterate this fact that the main aim and the objective of this demo is to just demonstrate this improvement process. We are going to go through all these steps from reviewing and identifying the targets for improvement, and then go through the next step, evaluating, and then start to think about how we can deploy and replicate this success. Chi, over to you.
OK. So yeah. Based on the improvement process that Sam outlined, the first step is to start with sustainability goal of the workload. Based on the AWS architected framework, we need to continuously look for opportunities and set goals to optimize the resource efficiency within a workload. This can be achieved through improving resource utilization and minimizing the total resources required to run the workload. For the purpose of this demo, let's set our goal to be improving our resource utilization by at least 50%. Resource efficiency by at least 50%. Now that we have identified our sustainability goal, we need to explore AWS well-architected framework best practices and tooling as covered by Sam to identify areas for improvement for our workload. In this demo, we are going to use best practices within a sustainability pillar of AWS well-architected framework to identify areas of improvement. So we do not use any recommendation of any tooling for this demo. As Sam mentioned, we have 6 key focus domains in sustainability pillar, and we explored those focus domains to identify areas that can help us to improve our Glue workload. After going through the exploration phase, we identified 4 areas that can help us to improve our Glue workload. Firstly, using the Glue auto-scaling mechanism with hypothesis that it can help improving compute utilization. Secondly, changing the join mechanism in Spark with hypothesis that it can help us to reduce data shuffling. And finally, changing the file format and Spark version, which can improve compute efficiency in our workload. Now that we have identified the area of improvement, we need to start to prioritize which we want to test and validate first. We all now team have limited capacity and bandwidth, so we need to make sure items which is easier and have low risk are added based on their priority. In our prioritization framework, we consider 3 key factors: the potential of change, and the effort and the level of risk for each scenario. We assess each of these factors for our improvement targets as shown at this table. At here, green one is better and the red one is worse. After assessing those prioritization factors for each scenario, this is the ordering for our scenarios that we are going to test and validate. So upgrading Spark version will be the first scenario to test, and changing join mechanism will be the last one. Now let's validate each of these scenarios to see if they can improve the resource efficiency of our workload. Earlier in this presentation, Thomas mentioned how we need to define the KPI for the workload in order to assess and evaluate specific improvements. This KPI defined as proxy metric divided by business metric. This is the way that we define the KPI for our demo workload. We will use the number of taxi rides as business metric and DPU hours as proxy metric. DPU stands for the data processing units used to scale an AWS CUDOS job. A single DPU provides 4 vCPU and 16 GB memory. As DPU hours is proportional to the amount of resources used by a CUDOS job, we will use this as a proxy metric to evaluate improvement scenarios for our demo workload. This is the way that we capture these metrics. We get the number of taxi rides as business metric from summarized data in S3, and also DPU hours from the AWS cost and usage report, which is automatically exported to S3 on an hourly basis. Finally, to enable more visibility, we get some granular metrics from Amazon CloudWatch to explain how its improvement impacts the DPU hour. We will use Amazon Athena to query the data from S3 and CloudWatch, and Amazon QuickSight to visualize the KPI and metrics. For this demonstration, we have created this QuickSight dashboard for the evaluation and discussion. Often, we blindly make improvement and report only the final improvement results, but this is not a good idea. By considering why we get results for each scenario, we can prevent unexpected events in the production environment. And by documenting what improvements were made and what results are achieved, it is easier to explain to stakeholders and visualize the improvements to other workloads. In this demo, KPIs and metrics are visualized on a single QuickSight dashboard, but you can use separately with CloudWatch and Grafana too. let's start with the first scenario, which is upgrade the GRU Spark version. Changing the Spark version is very easy in AWS GRU. Just one setting in GRU console. As the Spark framework is backward compatible, the risk for this change is not very high. We just upgraded Spark version from 2.4 to 3.1. By the way, GRU 4.0 with Spark 3.3 became GA today. So you can use this instead of Spark 3.1 at your GRU console now. Let's look at the results of changing Spark version. After this change, the QuickSight dashboard shows a 20% reduction of our KPI. To explain what happened here, we can use supplementary metrics from CloudWatch. As you can see here, the elapsed time for this job is reduced too. It is because of dynamic query planning with new Spark version that help to reduce the elapsed time and resource consumption. The second scenario is to change file format to Parquet. As I discussed earlier, the original file format was CSV, which is not efficient for big data processing application. Apache Parquet is an open source file format which is optimized for big data processing frameworks such as Apache Spark as used in this demo. So let's see how this file format change can help us to improve this workload and the sustainability KPI. Here is the result of this scenario. As you can see, the KPI dropped by another 30%. To explain this drop, we can use the S3 read byte metric in CloudWatch. As you can see here, the metric also dropped, which means lower I/O burden and lower resource consumption. For scenario 3, we just need to go to GRU console and tick the box for auto-scaling to adjust the number of workers based on load. AWS GRU auto-scaling mechanism adjusts capacity in real time, which reduces idle resources and improves resource utilization. For our case, this helped us to improve our KPI by another 10%. And finally, the last scenario, which is changing join mechanism. As for our workload, taxi zone table is much smaller compared to taxi rise table. So broadcast join would be more efficient for this join to join these two datasets. If we apply this join mechanism, we reduce the data transfer and shuffling across the cluster, which means reduction of our KPI by another 30%. Sam?
Awesome. Thanks, Chi. All right. So through a series of 4 improvements, we were able to actually reduce our KPI by 90%, which is actually more than our initial target, which was 50%. And because all those the improvement target actually help us to improve the KPIs, there are potential to be deployed in our live environment. So as you can see, you saw, we just use modern data architecture as of many workloads that you may have. And for your case, also, you need to, I would say, go through the same process if you want to improve it for sustainability. All right. With that, let's conclude this session. And let's talk about what we covered during this session. We talked about Amazon and AWS sustainability journey and some of the key initiatives that we got for our own sustainability transformation. Also, we talked about how how AWS can be a technology partner for you and help you in your sustainability transformation journey. Also, cover those key framework and tooling that can help you to make your architecture sustainable and high-performing. And also, through a demo, we talked about and demonstrate how you can improve a specific workload for sustainability. So if those types of content were useful and you are interested to learn more about sustainability, these are the number of breakout sessions that we're going to have during reInvent. So let me just keep it. So these are like all the breakout session if you want to take any photo. And also our workshop and chalk talks, which are all related to sustainability. With that, I would like to thank all attendees who just joined us in this session. I hope all the contents were useful. And just one last thing, we really love to get your feedbacks and comments. Please just use the survey in your mobile app and just provide with any comment or feedback you may have. And I think we are running out of time, but we are available for any question that you may have. We're going to just be around, so just feel free to comment if you want to ask any question. Thank you.